Oxidation state of Fe in K4FeCN6 is A plus 2, B minus 2, C plus 3, and D plus 4. Now let the oxidation state of Fe be X. Therefore, 4 into plus 1 plus X plus 6 into minus 1, which is the oxidation state of Cn, is equal to 0. Or X is equal to plus 6 minus 4, which is equal to plus 2. Therefore, the oxidation state of Fe is equal to plus 2, which is option A. So the following reagents is commonly used for the detection of sulfide ion. These are the options. Now, we know that the sulfide ion reacts with sodium nitroprusside to give a dark purple complex. The reaction is as follows: S2 minus plus Na2 FeCN5NO gives a dark purple complex, which is Na2 FeCN5NOS minus minus. Therefore, sodium nitroprusside is used for the detection of sulfide ion, which is option D. Oxidation number, d orbital occupation, and coordination number of chromium in the complex cis CrEn2 Cl2 Cl are respectively. Here are the options. Now let's find the oxidation number first. So let the oxidation state of Cr here be X. Therefore, X plus 2 into minus 1 is equal to plus 1. Therefore, X is equal to plus 3. Therefore, the oxidation state of chromium is plus 3. Now, Cr3 plus occupies 3d orbitals in this complex, and it has a coordination number of 6 in the given complex. Therefore, the correct answer is plus 3, 3d, and 6, which is option C. The following configuration can undergo distortion. Here are the different options. Now, let's first look at what is T2EG and EG. Now, repulsion by 6 ligands in an octahedral complex splits the d orbitals on the central atom into T, 2G and EG levels. It follows that there is a corresponding repulsion between d electrons and the ligands. If the d electrons are symmetrically arranged, then there will be no repulsion. Thus, the structure will be regular octagonal. If the d electrons are asymmetrically arranged, they will repel some ligands in the complex more than others. Thus, the structure is distorted. Therefore, the structure is distorted when the d electrons are asymmetrically arranged. Now, out of all the answer, option B, C, and D are symmetrically arranged, but option A is asymmetrically arranged. Therefore, the correct answer is option A. The correct order for the wavelength of absorption in the visible region is, here are the different options. Now let's look at the logical solution. Now the absorption of energy or the observation of color in a complex transition compound depends on the charge of metal, ion, and the nature of the ligands attached. The same metal ion with different ligands shows different absorption energy depending upon the type of ligand. The presence of a weak field ligands make the central metal ion to absorb low energies, that is of higher wavelength. The field strengths of the ligands can be obtained from the spectrochemical series, that is CO is more stronger than Cn is more stronger than NO2 is more stronger than NH3 is more stronger than H2O is more stronger than OH, and so on. Now if you look at the options, the first option matches correctly since H2O is more stronger, since NO2 is less stronger than NH3 is less stronger than H2O. Therefore, this is the correct answer, which is option A. An aqueous solution of CoCl2 on addition of excessive concentrated HCl turns blue due to the formation of, here are the options. Now, CoCl2 is blue when anhydrous and deep magenta is blue when anhydrous and deep magenta when hydrated. CoCl2 is also a weak Lewis acid, and when it reacts with a chlorine ion, that is HCl, it produces salt containing tetrahedral CoCl4 2 minus ion. Therefore, the correct answer here is option C. Which of the following statements is incorrect? A. In K3FeCN6, the ligand has satisfied only the secondary valencies of ferric ion. B. The ligand has satisfied both primary and secondary valencies of ferric ion. C. The ligand has satisfied both primary and secondary valencies of ferrous ion. And in D, the ligand has satisfied only the secondary valencies of copper. Now, let's look at the logical solution. Now, in both option A and D, they are both incorrect. Since in K3, Fe CN6, the ligand are negative. They are negative, which is present in coordination sphere, shows a dual behavior. So it may satisfy both primary and secondary valencies, while neutral ligands satisfies only the secondary valencies. Therefore, since here it is negative, it is not neutral. Therefore, it should satisfy both primary and secondary. Therefore, B and C is correct. However, A and D are the wrong answers, which is the correct one. EDTA solution is added to Mg2 plus ion solution, then which of the following statement is not true? A. 4 coordinate sites of Mg2 plus are occupied by EDT and remaining 2 sites are occupied by water molecules. B. All 6 coordinate sites of Mg2 plus are occupied. C. pH of the solution is decreased. Or D. Colorless chelate is formed. Now let's look at the reaction of EDTA, which is ETA 2 minus plus Mg2 plus gives Mg EDTA 2 minus plus 2H plus. Now, in the formation of this complex is 6 coordinated. Therefore, option B is correct. Now, this complex is also colorless. Therefore, option D is also correct. Now, increase in the H plus decreases the pH of the solution. Therefore, option C is also correct. However, option A is incorrect, since in this complex 4 donor sites are occupied by oxygen and 2 donor sites are occupied by nitrogen. Therefore, option A is the correct answer, or rather the incorrect solution. Which kind of isomerism is exhibited by octahedrous CONH34Br2Cl? These are the options. Now, first is exhibits NH3 NH3 Br 3 NH3. So this is a cis isomerism, which is a geometric isomerism, because we can change the position of NH3, which we can put Br right here and Br right here, and we can put all NH3 right here. So this would become a trans isomerism. We can also exhibit an ionization isomerism where NH3 CO 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 NH3 NH3 and Br and Cl. This is a cis isomerism, and it can also become a trans isomerism. Therefore, CONH34Br2Cl shows geometrical and ionization isomerism, which is option A. The following is an outer orbital complex and exhibits paramagnetic behavior. These are the options. Now let's look at the options one by one. Now, complex and their hybridization. So, FeCN6 4 minus, which is option C, has a D2 sp3, which is inner hybridization. MnCN6 4 minus has a D2 sp3, again an inner hybridization. And CONH3 6, which is option A, also has D2 sp3, which is also an inner hybridization. However, option D, nickel and NH3 2 plus, shows sp3 D2, which is an outer hybridization. Therefore, here the correct answer is option D. The process of extraction of gold, roasted gold ore plus Cn minus plus H2O gives X plus OH, and X plus Zn gives Y plus Au. Now identify the complexes X and Y in the following reaction. So these are the options. So now let's look at what the reaction takes place. Now, when roasted gold is treated with Cn plus H2O, it undergoes a reaction in the presence of O2 and it gives rise to Au Cn2 minus plus OH minus. And when this AuCN2 minus is treated with Zn, it gives rise to ZnCN4 2 minus. Therefore, the value of x and y is AuCN2 minus and ZnCN4 2 minus, which is option A. Spectrochemical series, chlorine is above water, that is Cl is more than H2O. This is due to A. Good pi acceptor properties of Cl, stronger sigma donor, and good pi acceptor properties of Cl, good pi donor properties of Cl, or larger size of the Cl than H2O. Now, when ligands are arranged in ascending order of the crystal field splitting energy, delta they produced are a spectrochemical series. In comparison to H2O, Cl is a strong sigma donor and a good pi acceptor. Therefore, it is stronger ligand than H2O. Cl is a stronger ligand than H2O. Hence, it is in the spectrochemical series, Cl is above water. Therefore, the correct answer is option B. Hydrolysis Me2CiCl2 will produce Me2CiOH2. Me2Ci is equal to 0. O Me2 is SiON, or D Me2Cl SiClOH. Now, when Me2CiCl2, which is SiClCl when it undergoes hydrolysis, it produces OCiOCH3N. Therefore, here the correct answer will be option C, OMe2SiON. In NiNH3,4SO4, the valency and the coordination number of Ni will be respectively A 3 and 6, B 2 and 4, C 4 and 2, and D 4 and 4. So let the valency of Ni be X. Therefore, X plus 0 minus 2 will be equal to 0. Therefore, X will be equal to plus 2. Therefore, plus 2 is the valency of Ni, and the coordination number of Ni is equal to 4. Therefore, the correct answer here is option B. Coordination number and oxidation state of Cr in K3Cr C2043 are respectively A 4n plus 2, B 6n plus 3, C 3n plus 3, and D 3n 0. Now, its coordination number will be 6 because it is bonded with 3 bidentate ligands. Now, to find, therefore the coordination number is equal to 6. Now, to find the oxidation state, let the oxidation state of Cr equal to X. Therefore, X plus 3 into minus 2 plus 3 into plus 1 is equal to 0. Therefore, X is equal to plus 3. Therefore, here the correct answer is B, 6 and plus 3. Bonded organometallic compound which has ethene as one of its component is A. Zeise's salt, B. ferrocene, C. dibenzene, chromium, or D. tetraethyl tin. Now let's look at the structures of all the four. Now in ferrocene, there are 2 rings attached to Fe. This is ferrocene. Now in dibenzene chromium, 2 benzene rings are attached to chromium like this. 2 benzene. Now in C2H5 4Cn, this is tetraethyl tin. Therefore, this also doesn't have a pi bonding organometal. But however, in Zeise's salt, which has the formula is given by Pt Cl CH double bond CH. Therefore, this has a structure K plus. Therefore, here it has a pi bonded organometal compound which has ethene. This is ethene as one of its component. Therefore, the correct answer here is A. CuSO4 decolorizes on addition of KCN. The product is A. CuCN4 2 minus, B. Cu2 plus get reduced to the form CuCN4 3 minus, C. CuCN2, or D. CuCN. Now let's look at the copper and the Cn aspects of both the complexes. Therefore, if these both reacts, this is Cu2 plus plus 2Cn minus. It gives the answer as CuCN2. Therefore 2CuCN2 gives 2CuCN plus Cn2, and therefore they declare as the formation of CuCN and Cn2 plus. Therefore the correct answer is option D, CuCN. Silver chloride dissolves in excesses of NH4OH. The cation present in the solution is A, Ag, B, Ag's NH3 2 plus, C, AgNH3 4 plus, or D, AgNH3 6 plus. Now let's look at the reaction. Silver chloride, which is AgCl plus 2NH4OH, gives the answer as AgNH3 twice Cl plus 2H2O. This on separation gives AgNH3 twice plus Cl minus. Therefore the cation given is AgNH3 twice, which is option B. Complex salt can be made by the combination of CO111 NH3 5 ClX with APO4 3 minus, B Cl minus, C 2Cl minus, or D 2K plus. Now when CO NH3 5Cl(X) reacts with chlorine, it gives a complex salt which is CONH3 5Cl(Cl2). Therefore, on reaction with chlorine, this gives a complex salt. Therefore, the correct answer here is option B, chlorine. Rather, option C, 2-chlorine. Any ferric salt, on adding potassium ferrocyanide, a Prussian blue color is obtained, which is, here are the options. Now, potassium ferrocyanide is given by 3K4 FeCN6 plus a ferric salt, which is FeCl3, gives a Prussian blue ferricyanide, which is Fe4 FeCN6 3 plus 12KCl. Therefore, this is the Prussian blue precipitate which is obtained, which is ferrocyanide, which is option D. Which of the following complexes has the highest stability constant at 298 kelvins? A, CdCl4 2 minus, B, CdBr4 2 minus, C, CdLi4 2 minus, or D, CdCN4 2 minus. Now, the cyano and the amine complexes are far more stable than those formed by halide ions. This is due to the fact that NH3 and Cn- are strong Lewis bases. Therefore, out of all the options, only option D has a Cn- complex. Therefore, the correct answer is option D. The correct statement with respect to the complete NiCO4 and NiCN4 2 minus is A. Nickel is in the same oxidation state in both. B. Both have the tetrahedral geometry. C. Both have square planar geometry. D. Have square planar and tetrahedral geometry respectively, or E. Have tetrahedral and square planar geometry respectively. Now, hybridization in NiCO4 is sp3. Therefore, geometry of NiCO4 is tetrahedral. Whereas hybridization of Ni in NiCN4 2 minus is dsp2. Therefore, geometry is square planar. Therefore, option E is the correct answer. Have tetrahedral and square planar geometry. The type of hybridization involved in the metal ion of NiH2O6 2 plus complex is A. D3sp2, B. sp3d2, C. sp3, and D. dsp2. Now, Ni2 plus has a hybridization of where 3 of the electrons are paired. However, 4s and the p electrons there are no electrons here. Now, in the presence of an H2O, the hybridization changes. The d orbitals remain the same with 2 unpaired electrons, whereas the s has no paired electrons and the p also have no paired electrons. Therefore, this hybridization is known as sp3d2 hybridization, which is the correct answer, option B. The ion of the least magnetic moment among the following is A. Ti plus 3, B. Ni plus 2, C. CO2 plus, and D. Mn2 plus. Now let's look at all the magnetic moment of all the four options. Now Ti3 plus has a magnetic moment in Bm as 1.75. Ni2 plus has a magnetic moment of 2.76. CO2 plus has a magnetic moment of 3.86, and Mn2 plus has a magnetic moment of 5.96. Now the magnetic moment of Mn2 plus is more because there are more number of unpaired electrons, 5. CO2 plus has 3, Ni2 plus is 2, and Ti has 1. Therefore, the more number of unpaired electrons, more is the magnetic moment. The correct answer here is therefore option D, Mn2 plus. I'm sorry, the question was the least number of the least magnetic moment, which is option A, Ti3 plus. Mn has the most magnetic moment. Therefore, the correct answer is option A. Magnetic moment of a transition metal ion is root 15 bm. Therefore, the number of unpaired electrons present in it is A4, B1, C2, and D3. Now, according to the formula, magnetic moment, which is mu, is equal to root of n plus 2, where n is equal to the number of unpaired electrons. Now given mu is equal to root 15, therefore root 15 is equal to root of n into n plus 2. Squaring both sides, we get 15 is equal to n into n plus 2. Therefore this is only possible when n is equal to 3. Therefore the correct answer is option D, 3. Moment of NH42 MnBr4 is dash Bm, A 5.91, B 4.91, C 3.91, or D 2.46. Now the magnetic moments formula is mm is equal to root of n into n plus 2, where n is the number of unpaired electrons. Now MnBr4 2 minus Mn has plus 2 state D5 ion, and in sp3 hybridization. Therefore, the number of unpaired electrons will be 5. Therefore, substituting the value, we get mu is equal to 5 into 5 plus 2, which is equal to 5.91 bm. The correct answer here is therefore option A, 5.91. The reaction FeCnS6 3 minus gives FeF6 3 minus takes place with a decrease in magnetic moment, increase in magnetic moment, decrease in coordination number, increase in coordination number. Now F minus is a weak field ligand, and CnS minus is a strong field ligand. Now therefore CnS minus is a strong field ligand, and in FeCN6 it has an inner orbital complex which is given by therefore it has a D2 sp3 hybridization, and the magnetic moment here is actually 0, since there are no unpaired electrons. However, F minus is a weak field ligand, and there will be, and the hybridization is given by, there is only one electron which is paired and the rest of the 4 electrons are unpaired. Therefore, magnetic moment definitely increases in FeF6. The correct answer therefore here is B, increase in magnetic moment. Moment of a salt containing Zn2 plus ion is A0, B 1.87, C 5.92, or D 2. Now magnetic moment mu is given by root of n into n plus 2, where n is the number of unpaired electrons. Now in Zn2 plus, the configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s0, and 3d10. Therefore, there are no unpaired electrons in the d orbital, and n is therefore equal to 0. Therefore, the magnetic moment will be also equal to 0. The correct answer here is therefore A, 0. What will be the theoretical value of magnetic moment when Cn minus ligands join Fe3 plus ion to yield complex? Now, Fe3 plus ion has a 3d5 hybridization. Therefore, all the 5 electrons are unpaired. Therefore, all electrons are unpaired. When Fe joins Cn, however, Cn is a strong field ligand, and therefore the electrons get paired and only one unpaired electron is left. Therefore, Cn is a strong field ligand, so it forms low spin complexes after pairing of electrons. Therefore, the magnetic moment is given by root of n into n plus 2, where n is the number of unpaired electrons. Here the number of unpaired electron is 1. Therefore, 1 into 1 plus 2, which is equal to 1.73. The correct answer here is option D. The following complex does not show geometrical isomerism. Here are the options. Now, octahedral complexes of the type MA4X2, MA3X3, MA4X4, MAA2X2, MAA2XY exist as cis and trans isomer. Now, out of all of the options, option C has a cis and a trans isomer which looks like this: OX, 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 OX. Now, this is a cis, and the trans is also the same as the cis. Therefore, they cannot exhibit geometrical isomerism, and therefore, the correct answer is option C.